I wanted to share with you a project I've been working on for the last few weeks, which is called Defi Yield Hunter. Defi Yield Hunter is a project that allows users to add their wallets, and it will then scan that wallet on various chains. In this version, it will be just for Ethereum and Base. And it will scan that wallet for idle assets being held. These assets are also whitelisted to just be the core assets such as ETH, USDC, USDT, Link, and a few others. And it will also, in particular, check what positions the wallet holds on various DeFi protocols. And the DeFi protocols that I'm targeting in this version is Aave and Uniswap v3. So without further ado, let's take a look at how this works. So we've got this login screen. I'm just using Clark to do that. Now, I've got a wallet that I'm going to grab. This wallet here is not my wallet. It's one I found on chain, and it is a Uniswap holder. It's a wallet that I found that has a position in Uniswap v3. So you add the wallet and then you click scan. Once you click scan, this fires off in the back end. In Amazon, in fact, Amazon Web Services, it's running a Lambda function to run a scan of this particular wallet. And not only does it scan the wallet itself, but it also takes information from various news feeds, DeFi protocol APIs, exploit information, and all kinds of other information. It's gathered together, and an AI agent called a portfolio AI agent, which we'll take a look at in a minute, basically takes all that information and analyzes the wallet's holdings for recommendations. So as we can see, the scan has completed and it gives you a little summary. The summary tells you how much the wallet holds. It gives you a bit of a blurb on where the positions are held in, and as I mentioned, this is Uniswap v3, and and it also says there's some idle capital which could be deployed, right? So we've got the number of positions, some opportunities, a bunch of observations, and then under the per wallet recommendations, we've got all the holdings that the wallet has. You can see here that it's got some USDC on Base, but it's also got a position open on Ethereum and a little bit of ETH on Ethereum and some USDC on Ethereum. It also isolates the positions that it has open. So it currently has a position on Uniswap v3 with fairly high yield, and it recommends that to hold that position. But it also says that there is obviously impermanent loss risk and some volatility. And this is gathered from data that has been imported via another agent that basically scans the web periodically and adds information about opportunities on chain. And speaking of opportunities, there's an opportunity here for the user to deploy their idle USDC. They should deposit this as recommended into Uniswap v3 Base. This is one of the ones that the AI agent has recommended. So without further ado, let's take a look at adding what happens when we add another wallet to the same account. So this wallet here is an Aave holder. So Aave holder, we add the wallet and we click scan again. And when the scan is complete, it's now going to scan both of these wallets and give us some portfolio advice, but this time for both wallets. Okay, and the scan is completed, and as we can see, the portfolio summary has updated, and we have $26,000 in the value of the portfolio now. And there is an observation about Aave exploits, and you can see the Aave holder wallet portfolio is showing here. So you can see the holdings. They have 8.28 WETH deposited into Aave, and we can see that listed here as a position with the APY. And it recommends to exit, I think, because of the recent exploit risks that have occurred. And also there is a position on Aave for the USDC. Moreover, it's recommended a couple of opportunities where you can get a little bit of high yield and a rebalance opportunity here saying that we could move our USDC from Aave to Uniswap and get a jump in yield of about 99%. As expected, the Uniswap holders' positions are still being displayed after that. And one thing you'll notice is there is a link to Etherscan and Basescan for each of the wallets, which we can check, and it opens straight up into the wallet's holdings, and we can see here that it matches what we have scanned. They hold this RA position and they hold this link position. And if you remember, of course, this protocol, this product here, the DeFi Yield Hunter, is whitelisted to only Base and Ethereum. Only a handful of tokens such as ETH, USDC, USDT, Link, and only 2 protocols right now, which is Uniswap and Aave. So that's the demo of the product. Now I'd like to dive in a little bit into the code and how the AI agents work. Okay, let's dive into the architecture. Now here I have open the repository and I've got the README file open. Right now, by the way, the repo is closed source, but I plan to open source this in the near future. There are 2 main components to the architecture. One is the portfolio agent, which we also already saw running in the front end there, and the scheduled producers. Now, the way this works is the scheduled producers are run on a schedule, of course, and it kicks off a researcher lambda. Essentially, this is a agent that will use a variety of tools, which we'll look at in a minute, to get information on the internet for exploits and for news and for discussions on all the whitelisted protocols that we support. It will gather that up into a document and post that to the ingest endpoint. And the ingest endpoint, this arrow goes all the way over here and back here, it actually ends up calling SageMaker. And SageMaker is running a small open source sentence transformer, which I downloaded from HuggingFace. In fact, SageMaker has containers that you can download. And in particular, this is a HuggingFace PyTorch inference deep learning container. In fact, I've got the model that we're using open here in HuggingFace itself. As you can see, it is this transformer. And what it does is it takes the text and converts it to a 384 dimension vector. And once that is ready, it will then save that to the S3 Vectors Research Index database, essentially, which is a new product, fairly new product from Amazon Web Services, which is essentially a vector database, but using S3. It's massively cheaper than some of the other ways and other services for vector databases. And there is a second lambda that runs on a schedule, and this is called the DeFi Llama ingest lambda. And that doesn't use an agent, it just will scan DeFi Llama for the latest pools and for their yields and for their TVL and other data, and will write that as a Parquet data type into a data store, which is actually S3 as well. But I've added Athena on top of the data store so that we can query these Parquet files with ease and using standard SQL. Now, in fact, all of this data is ingested into these databases. So we've got a vector database, we've got the Parquet database, which has an Athena front end, and we also have a DynamoDB database, and that's where we actually store the user's data. So when I log in, I create a user ID, and I add my wallets. This gets stored into DynamoDB. And also, when the portfolio agent runs, this is kicked off by the end user. So from the front end, this will actually call into this portfolio lambda, and it will kick off a new job. And the job is added to DynamoDB, and then the portfolio lambda will read in an augment, if you like, using tools, because the portfolio lambda is actually under the hood, it's another agent. And this agent will use at its disposal tools that it can call to fetch the data that it finds it needs to help with the portfolio recommendations. So it's going to read into the vector database to do a vector search on news. It's going to run SQL against the Athena database to get yields and other data specific to the pools that we support and that match the wallet that the user has. It's going to look at the holdings information that is in DynamoDB, and then it's going to basically save that into DynamoDB as a updated portfolio. And this, of course, uses an LLM because it's an agent, and the LLM can also be swapped out to use Anthropic or even an open source model if you so choose. So that is the architecture of DeFi Yield Hunter. So now we've covered off the architecture, let's dive into the code a little bit. So if you open up the folder structure, you'll see it's quite straightforward. At the top level, we've just got backend, front end, and Terraform. That's pretty much it. And so if we look at Terraform, there are 3 folders, and the most interesting one is app. That's where most of the definitions of the resources for Amazon are stored. And I've got a README in here that explains how you can run this and how you can have it for different environments. So we use workspaces in Terraform. And if we open up the main file here, we can see all the different definitions. We've got IAM roles, we've got the gateway, the researcher, we've got the scheduler role, we've got DeFi Llama ingest and S3 buckets and Athena, DynamoDB again here. So we've got everything is defined in Terraform. And the beauty of Terraform and doing it this way is that we can just define our variables in the TF vars, and we can run Terraform plan to see what changes will be made on the back end, and then run Terraform apply to actually apply those changes. And it's very easy to use Terraform in this way for provisioning resources in Amazon, but also in other cloud providers. So it's a very powerful tool, highly recommend it, and I'm using it in this project. Okay, next up, let's look at the backend code. If you expand the backend folder, you'll see there are a number of different sub-projects. Each one of these is essentially a Python project. And you'll notice that a lot of these have already been covered in the architecture. Now, if we look at the researcher, which is one of the things we discussed, this is what gets kicked off on a schedule to ingest news and information from the internet. And when it kicks off, it will kick off the Lambda handler. And as you can see here, we've got some observability, which we'll look at in a second. But eventually it's going to run the agent, which is this async IO call, because the run research function is a subroutine, not a function. And it is also wrapped with this trace, which is OpenAI trace. The agent itself is very straightforward in terms of how it's defined. It has a system prompt, which is defined in this function here, get agent instructions. It passes in the model, which is based on the model ID. And the beauty of this is we are able to swap that out, as I mentioned before. As you can see here, by default, it's using Amazon Bedrock's Nova Pro, but I am currently running this using OpenAI. But it can also be Anthropic or another model that you want. And the tools are the tools which this researcher can use to find information online. So you can see it's looking at DeFi Llama for various information about protocols via DeFi Llama, as well as some news on Rect, which gives information about different exploits that have happened, and general fetch URL. And finally, it also will call this ingest DeFi research function, which actually will then ingest the documents that it finds to the ingest API URL that I mentioned earlier that runs the sentence transformer model to embed it into the S3 vectors storage. So the instructions for the agents are defined here. It's basically a system prompt that explains what the date is today, how to work quickly and what it should be doing. And also there's a default prompt if the agent is kicked off without any specific topic. So yeah, that's basically the research agent and how that works. As I mentioned, we'll run this again and look at the traces and we'll look at the logs. But I want to just jump over to the next agent, which is the portfolio. This is probably the most interesting one. Similar kind of structure. As you can see, it's a Python project. The handler, again, is a Lambda handler function. It takes in the job and the user's IDs. And again, we're wrapping this with observability so that we can look at this in LangFuse. And the actual agent is called down here, where we call the run analysis function. And if we take a look at that, you can see, again, similar structure here. We're using the LiteLLM agent model here, and we're able to pass in the instructions for the system prompt. The model, again, is set to a default or overridden based on the key that you add. And there are some token settings here for the model, as well as a number of tools which the portfolio agent has at its disposal. So it's going to query Athena for the APYs. It's going to call search news exploits to see if there are any exploits in the protocols being reviewed, as well as run this tool to find the best pools for the assets. And all of the results come back after the run has completed, and then that gets sent to DynamoDB. So the other projects here, we've got an API, which is just a standard sort of REST API. We've got an Athena wrapper. This is just for actually creating views. Doesn't do much more than that. The database project here is actually a shared library, and we've got a class called repo that wraps calls to DynamoDB, like upsert and get user and so on and so forth. The Defi Llama ingest is another Lambda function, but it doesn't use an agent. It just basically reaches out to Lambda API, Defi Llama API, and ingests data from Defi Llama directly. And then this ingest handler is, as I mentioned, calls into the SageMaker endpoint to then convert the documents into embeddings to save into the vector database. So that's pretty much the back end. Quick whirlwind tour of the code there. And finally, before we dive into looking at the logs and looking at some of the traces, we have a front end. And the front end is just a standard Next.js app. Nothing terribly interesting here. It's vanilla front end code. And I think this is just something we can look at later. So that's as far as I want to go for now with the code review. Let's look at the traces. Okay, we're back in the DeFi Hunter application here. I've already added the wallet here, the Uniswap user. So I'll just click the add wallet button there, and then I'll click scan now. And what we're going to do is take a look at some of the logs. So if we look here in the CloudWatch logging, you can see here we got the log groups for the different Lambda endpoints as well as the embedding endpoints. Now, if you remember from the architecture, it's the portfolio Lambda that is called when a run or a scan is executed. You can see here that the latest log stream is showing, and if we click resume, it will essentially follow the tail of the log and keep adding more logs. So as we can see, it started to call some of the reader wallets, so it's got the list of different tokens. It's then started a trace for OpenAI, and this is the agent ID. So let's take a look at the OpenAI traces, and we can take a look and dive into that. So we click that one, and we can see here that's the corresponding trace that's been logged into the OpenAI traces. And if we look in generation, we can see the system prompt here. And if we scroll down, we get the user prompt, which has come from the agent code to analyze the portfolio with all the actual portfolio data there. And the response from the agent has been, not surprisingly, call a bunch of tools. And this is the request that gets sent back by the AI, by the LLM, to then call these tools. And we can see here that in traces, we are indeed calling these tools, and we are calling history to get a history of the APY for a particular pool. We're looking at news exploits, in this case for Uniswap, which makes sense because this is the Uniswap holder, so they got positions in Uniswap. It's also looking at Arve as well, probably because there's some Arve positions that it should check on. And then it's looking at the best pools for the asset. So it's going into Athena to check the different available pools and the yields that could be recommended to the user. And finally, at the end of the trace, we see the full output of the system prompt with the tool requests, followed by the tool responses that then get fed back to the LLM. And finally, right at the end, we got the final report, which summarizes the repo. And you'll see it's structured as well because we're using Pydantic and we've requested that the agent returns structured output. So that's why we're seeing this content here is actually structured JSON output, which, by the way, gets validated in our code. Now, as you remember from the code review, we also wrapped our calls in observability parameters, and this is for LangFuse. LangFuse is an awesome tool that monitors a lot of data for your agents. And you can see here I've used it over the last few days. We can see the costs, we can see the usage by type and by model. I've used mostly, as you can see here in this test, Nano GPT 5.4 in this case. And we can look at maybe some other historical data. Let's look at the last 7 days perhaps. You can see here that I've used Bedrock as well, and Bedrock doesn't actually come with costs logged in LangFuse, but yes, we can see that over time you can see if you've changed the models or changed any parameters, you get some very useful feedback. Now we've got a trace that's come in, that would have come in the last recently for the call that we just made. That's about it there, and you can see again the same kind of flow here. The agent has made a call, this is the metadata, and it's come back here. We've got the system prompt, we've got the user prompt with the portfolio, we've got all the different tool queries made or tool calls made by the agent there, or requested to be made by the agent. And then at the end we got the output of the entire flow. And so this is a really, really useful tool that I highly recommend to use. It's helped me a lot during the building of this application to help debug the agents and make sure that the tools are being called as expected. Now I've also got a dashboard here that I created in CloudWatch. You can create these to just monitor your infrastructure, monitor the back end, monitor the performance of Lambda, of your databases. So here are a couple of examples, and I'm looking at error rates, I'm looking at execution times, I'm looking at concurrent executions. And also we can take a look at DynamoDB. If you remember from the code review, DynamoDB is where the code saves the user's portfolio and recommendations. So we can filter by job ID. We can get that from the run. So here we can see the run is complete. And if we copy that job ID and enter it into here and click run, we'll see the job ID for that user. And if we click into that, this is indeed the actual recommendations that we have got from the front end. So you can see positions has two values, value 0, value 1, and you can see it's the WETH USDC position, which you can see down here under positions, represents this one here, this WETH USDC position. So yeah, this is where all the data is stored for the users. Obviously, DynamoDB also has other tables like the snapshots for the portfolio snapshots, the users database, which just basically keeps a list of the users, and the wallets, which we've been using over time for testing. You might be interested to just take a look at Athena here. I've got a query open which shows the last supported pools, so we can run this and that will give us the output in a table. The great thing about Athena is that it works with SQL, even though under the hood this data is coming from S3 Parquet data format, which is pretty awesome because we can basically save that into S3 and query it nice and easily on this front end. There are two tables that we are saving, basically related to the pools, snapshots, and protocol snapshots. And then I've got some views, which are views into those two tables. So we've got history for over 7 days, which is one of the things that the agent calls regularly, as well as latest snapshot information and latest protocol information. So yes, that's pretty much an overview there. Obviously, everything is Lambda based. This whole application is serverless. Let's take a quick look at the architecture again. And just to remind ourselves, but that was really it. That wraps up this video. I hope you enjoyed it. We went through a demo of DeFi Yield Hunter. We reviewed the architecture. We did a brief code review, and then followed by some logging, observations, and agent traces. So if you want to take a look at this, I will be open sourcing this repo in the near future, and I will also publish this on a endpoint at some point too. But when it's open source, of course, you can just basically clone this repo and review and run this locally, and you can run it in the cloud as well. And before I wrap up, I just want to show you something about local development, how I've been doing this, because since this is all running in Amazon and it's all serverless, I wanted to have a way where I could easily test the front end, the lambdas, any of the back-end things, and the AI, of course, the LLMs and the agents. I wanted to be able to easily have visibility and quickly just spin things up locally and run them and test them. So what I've got is a setup where I can run things locally using dev server. So if we just take a look at the local host here, you can see that it's not running. If I start the local host now and go back to that, I've configured the localhost backend now to point to a locally running API. So we're getting failed to fetch. That's because I haven't started the API. So here in the API folder, I have a dev server, which is now running the local API. So if I run that now, if I refresh, we can see that it's got the portfolio here. And if I want to run a scan, I can run everything locally, because this API here that's running here is going to be calling into another service locally here. So I just run the portfolio in this window, and then I can come back here and click scan. And then when I come back, you can see here that it's running the scan. So that's pretty awesome. And now that will just basically complete, and it's all running locally. It's not running in Lambda. But one of the things that I have kept in Amazon is the database. So when the job runs, it still queries Athena, it still uses S3, and it still saves everything to DynamoDB. But this is really great for visibility running this locally. Moreover, the researcher can also be run locally. I just start up a dev server. And if you recall, the dev server requires another endpoint, which is the ingest. And it says here that if we want to trigger a run, then we can trigger it with a particular topic using this curl command. So this curl command here is running to port 8003. So if I just paste this into this window here, this curl command hits this endpoint, which is the researcher, and now it's running the DeFi researcher using, as you can see, it's using OpenAI GPT for 5.4 mini. And you can see that the ingest has been hit as well. And so, yeah, this is all working and running locally. And of course, the DeFi Llama endpoint and Lambda can also be run locally, and that just runs on its own and can be used to ingest data from DeFi Llama. So as you can see, the completion has finished here for the portfolio, and also the researcher has finished. So everything's running locally, and it's just a nice way to develop this application if you so wish. And that's it for today's video. I hope you enjoyed it, and I hope to see you again soon.